So today I'm going to be giving an introduction to linear relationships. So a linear relationship describes a straight line relationship between two variables. This can be shown as either a graph or a mathematical equation of the form y is equal to mx plus b. You're going to see this equation a lot in the coming years, or if you continue with mathematics in general. So I'm going to break it down into the individual variables you see here and tell you what they mean. So first of all, the y value is the dependent value. So you're going to put in a certain value into this equation, and the y value is the value you get out of the equation, the output. It is dependent on the value that you input, so it's called the dependent variable. On the other hand, we have x, and this is the x value, which is an independent variable. Independent means that you can change it however you like. You can put in whatever number you like into the equation, 1, 2, 3, 4, etc., and you're going to get a different y value output depending on that. M is part of the slope, or M is the slope. It is equal to the rise over the run. So that's the change in y values over the change in x values. This will make sense a little bit later on. And b, the value of b is the y-intercept, and this is where the line that's part of the straight line relationship crosses the y-axis. To make this make a little bit more sense, we're going to first start off from a base equation. We're going to create a table of values, and then we're going to look at that equation and how it plays out on a graph. Remember, there are two ways that that a linear relationship can be expressed. You can express it as a graph or as a mathematical equation, and here we're going to take a look at both. So here, y is equal to x plus 1. So we're going to change our x values, and then we're going to get a set of y values out. And if we put these on the graph, then it's going to show us what that equation looks like. So it's good to have a range of negative values and of positive values. So let's start with -3, -2. We don't have that many. Hang on. So we'll have an intermediate value of 0, go lower, and here we go. So what happens if we plug in -2 for the x value? -2 plus 1 is -1. So we fill that out. Now, what if x is equal to -1, like we've written here? Well, -1 plus 1 is equal to 0. How about if x is equal to 0? Then y is equal to 1. And if x is equal to 1, y is equal to 2. If x is equal to 2, y is equal to 3. So let's take a look at why this is. If we write out the equation, and instead of putting the variable x in these brackets, we can put whatever x value we choose. So say -2. Then we simply use our algebra skills, and we can say to ourselves -2 plus 1 is -1. Therefore y is -1. We repeat this process for each value of x, and this gives us a set of y values. We can then use these values on the table to give ourselves a look at the graph. All right, so that's where that point comes from. Next, if we look at our table of graphs, we have the point -1, 0. So if we look for those areas on the graph, when x is equal to -1, for the x-axis we have here, and then the y is equal to 0. When x is equal to 0, or the x value is equal to 0 and y is equal to 1, if we write that on our graph, we have this point right here. If we continue on and we look at our next point, point 4, that's just what I've labeled this point here as point 4. Then we can see that x is equal to 1 and y is equal to 2. You can start to see a pattern emerging, a straight line pattern, and this is good because we know we have a linear relationship. If we didn't have a straight line, we'd need to be worried. And then our final point here, x is equal to 2, y is equal to 3. There we go. So we can draw a straight line through all of that. And this is what our equation looks like on an actual graph. So let's try our next problem. So let's use some values here. I'm going to go with the same ones. Remember, you can use any points for this x value here. I'm choosing ones that are close to the center of our graph, so it's easy to take a look at what's going on. But technically, you could put any numbers here, like 10,000, 10,001, 10,002. But for the sake of our demonstration, it's easier to do the calculations if you have lower values of x. So let's get started. Let's start with our first example. Y is equal to 2. Then we have our little bracket or area in parentheses here. So let's put in our first value of x, which is negative 2. 2 times 2 is 4. So we're adding a negative in there because of the negative sign. Plus 2. Therefore, we're getting a y value of negative 2. We'll write that down. We're doing the same process for each number we have. I'll do a few more. All right, so let's write these values down. First, I'm just gonna write our little values on this graph really quick. Okay, so now let's write down our points. X is equal to negative 2, y is equal to negative 2. Write that point down. X is equal to negative 1, y is equal to 0. Write that point down. X is equal to 0, and y is equal to 2. Oh. Write that point down as well. X is equal to 1, and y is equal to 4. And finally, x is equal to 2, and y is equal to 6. We can see here that there's also a line emerging. We can see here that these graphs don't look exactly the same, even though that they're a straight line or a linear relationship. The reason that they look different can be explained in following videos. But for now, we can just see how we can take an equation, a linear equation, we can substitute in values for x of our choosing to create an output of values of y, and once we put these coordinates on a graph, we can see how that equation is expressed in a visual manner.